and share the screen and open what I have started for your notes. Today, we're going to look more at the standard deviation, and this is the standard deviation. It's going to lead us to a discussion of something that's called the normal distribution. And if you go on to take a statistics class, you're going to see that an awful lot of statistic revolves around this idea of this normal distribution. At some point in time in your life, you might have heard discussion of a bell curve. That's what we're referring to with the normal distribution. Homework 15, which is on mean, median, mode, and mid-range, is to be done by the end of the day today. Homework 16, which is on some of the standard deviation stuff, is not due for a while, but start looking at it. On Friday, I'm going to have available a quiz on central tendency, so it'll be available in my math lab after class until 11:59 Sunday, which will be the what is the date on Sunday? The 8th. And also just looking into the future, does everybody know that November 11th is Veterans Day? And the campus is closed for Veterans Day. Okay, and everybody
Okay.
that's not usually a Monday holiday because it's the armistice that was the end of World War One, and it was on the 11th day of the it was signed at the 11th hour of the 11th day of the 11th month, and so it's always on November 11th. A little bit of history.
Thank you.
Which I don't know. Did you guys know that or not? It's always November 11th because of that. So before we get started from where we left off, looking at that standard deviation, does anybody want to look at anything from homework 14 or 15? Those homeworks are going okay for everybody? Nobody has a question on them. Also, there was that quiz on organizing data that an awful lot of people in class did not take. If you fall into that category, please send me an email as soon as possible. 2 ways I can adjust for people, 3 ways I can take into consideration people who did not take a quiz. 1 is be harsh, not let them take it, and it's a 0. 2, let them take it, give them 1 more day, but have a late penalty. Or 3, let them take it for full credit, and to compensate for the people who did get it done on time, give the people who did get it done on time extra credit.
Yes.
So I want, you know what? I have never used a poll in here. I don't have a question to add. So I guess I'm not going to use a poll because I've never used a poll and I don't know how to. That would have been a fun way of doing it, but it's beyond my capabilities right now. Let's go back to class. Stop sharing the screen. Let's go back to class view. Oh, I can't see your faces because most of you are hiding. Damn it. What do you folks think? I was going to say, raise your hand. How many of you think I should just not let people take it? Anybody just do say something if you think I should.
I like the last one you said where that you don't take points off for them. And if you did it done on time, you get extra.
I like that one too.
Is that what most people like?
Yes.
Yes.
Okay.
Yes.
because I don't want to see half the class get zeros, although shame on you guys. I told you that quiz was there. Why did you miss it? Oh, sorry. But I don't think it's fair to people who took it on time to give equal footing to everybody. The two ways of dealing with it, extra credit or penalty. If you guys like the extra credit, that's what we'll do this time, okay? So going back to sharing the screen then, so I'm not going to discuss the quiz right now, that last quiz, and this will be the only time I allow lates. Otherwise, nobody has any questions on homework?
Do you want to do the homework that is due today?
Yeah.
I think it's number 21 or something.
Number 21 or something like that. Oh, there was the thing.
The one I'm talking about, GPA.
Okay, that's a good one to look at. That was homework for 15. And I'm waiting. Oh, here it is. It's coming. It's coming. And was it the last question?
No, not the last question. I think it's the second to the last.
Okay. Yeah. So each grade is worth a certain number of points. An A is worth 4, a B is worth 3, a C is worth 2, a D is worth 1, and F is worth 0. You have grades that are there, but it's a weighted average. It's a number of credit hours that you need to look at. So thank you for asking about this, because I did want to do one of these together with you guys in class and I had forgotten. So when I look at my data, my data values are my grades. And so we have 3 Bs, which are each worth a score of 3, and a C, which is a score of 2. Now, when we looked at an example of a weighted average, we looked at a frequency distribution, where we looked at each data value having a frequency. When we're looking at a grade point average, which takes the place of the frequency, is the number of hours. And so that first B was in a 4-hour class, that second B was in a 5-hour class, that third B was in a 5-hour class, that C is in a 5-hour class. Everybody with me so far? Then, when we had a frequency distribution, we said we wanted to add the total number of hours. So that would give me 19. And then we said what we did to take into consideration the fact that there are 4 3s, there are 5 3s, there are 5 3s, and there are 5 2s, is we took the score and multiplied it by its frequency. So multiplying across 3 times 4 is 12, 3 times 5 is 15, 3 times 5 is 15, 5 times 2 is 10. And we totaled that column, which gives me 2, 1, 2, 3, 4, 52. And so we said that the mean was equal to the total of the data value times the frequency over the sample size, which was the total of the frequency. So that gives me 52 over 19. And so now 52 divided by 19 gives me approximately, they want it to the nearest 100, So my grade point average would be rounded to the nearest hundredth, 2.74. A B is 3, so it's a little bit lower than a B because of that one C, but it's higher than a C. Have any of you seen that level of computation before? Does it make sense that it's a weighted average, that classes that have more credit hours are going to affect your average more than classes that have fewer? And so the number of credit hours works like the frequency. And quite honestly, this is the way your grade point average is calculated. However, usually instead of just A, B, C, D, and F, there's, A minus, B plus. And so each of those is given a different weighting. And if you look at the college catalog, that weighting is in there. And so if you take the grade times the number of credit hours, take those products, add them up, and divide it by the total number of credit hours. That's how they figure it out. Okay. All right, any questions on that? Is that one better? I know it's a little bit different than what we did in class, which is why I had initially intended to make sure I went over that with you. But I also think because that's the way it's done, you folks probably ought to see how this applies to things that are used commonly, like your grade point average.
Mm-hmm.
Can I erase this, or do I need to leave it up for a minute more? Are we done with this or no? Thank you very much for asking about that one. I think, Rachel, you were the one who asked, yes? Does anybody have questions on any of the other homework problems?
Currently, no.
If not, I'm going to tilt my screen a little bit so I can write on it a little bit easier. And I'm going to go back to that outline for the notes. And if I remember correctly, last class, we had looked at how to find a standard deviation. And we had found the standard deviation by looking at a table. We had a list of 4 students, each of which had the same average, but their grades were very much different. So from last class, we had looked at student A. We had said that their mean was 85. Their range was 10. And their standard deviation was, oh my heavens, what did we get for that? I'm looking and I'm not, 3.8. And in order to find the standard deviation, we made a table. But we didn't really ever work out the formula for the standard deviation. For the standard deviation, what we did was we took our data values to find the mean. We subtracted the mean from each of the data values. We then took those differences and squared them, added up the squares, divided by 1 less than the number of values, and then took the square root. And so if you ever look up the standard deviation, and again, this is the sample standard deviation, there's a slightly different formula for population. That's what you'll get. The formula, that idea of standard deviation, is used commonly enough that if you're ever in Word and you look at the functions that are built into math, I do believe that the formula for the standard deviation is one of those built-in functions. But does that formula do it for you, or would you guys rather go through and do that? It is a process making a table.
I don't know.
let's go through and let's look at some of those other students and see what conclusions we can draw from the standard deviation. Let's
This one
find
hopefully easier to remember.
the standard deviation for student B. And again, for student B, we had said that their mean was 85. We had said that their range was 30. And so there's a bit more spread in the grades for student B. Again, to make a find a standard deviation, I like to make a table. In the first column, I put the data values, which were, whoops, I did not mean to write that number there, I apologize. Which I labeled that as X sub n, my data values. They were 75, 70, 85, 100, and 95. We have to find the mean, and while we know it already, I'm going to add up this table just to remember that that's what I need to do to find the mean. And there were 5 numbers, and so we got the mean to be 85. Then this next column isn't essential, but I do think that for most people, it works better if you put in your mean. And I'm not gonna lie, filling in the rest of the table, I think it's easier if you fill it in going sideways instead of up and down. So the next column, we're gonna take the data values minus the mean. And in the last column, we're gonna square those. And so, working across, everybody with me, or do you need me to hold my breath and stop for a minute and let you catch up writing wise? Or are we good?
Okay.
So going across, 75 minus 85 is negative 10. And when I square negative 10, I get 100. 70 minus 85 is negative 15. And when I square negative 15, I do believe I get 225. That's going on memory though. Do you guys want to check me? I'll check. 15 squared is 225. We're good. 85 minus 85 is 0. Squared is 0. 100 minus 85 is 15. Squared is 225. 95 minus 85 is 10. Squared is 100. Again, you don't need to necessarily add this column, your deviations, but I like to do it as a check. And because of the positives and negatives, it adds to 0. And that fact helps me remember the reason that I'm squaring them is to make those all positive. And so it helps me to make sure, I want to double check and make sure I do not put a negative number in this column. And now going through and adding those, I get 650. And before we go any further, I'm going to go up here to the formula for a minute. Is everybody all right? That 650 is what would be in the numerator of this fraction. We took each value, subtracted the mean, squared it, and added them up. So everything that's done in that table is just figuring out the value for the numerator of that fraction. Now, when we found our mean, we said our number of values is 5. So we want one less than that, which would be 4. And so we're going to take that 650 and divide it by 4. And so when I take my 650 and divide it by 4, I get 162.5.
Yeah.
And so then for my standard, that's my variance. For my standard deviation, I take the square root of that. And when I take the square root of 162.5, again, we're going to round this, and this would be the first that I'd round here. When I take the square root of that, rounding to the nearest tenth, I get 12.7. And so this person's standard deviation is 12.7. Let's look at that. If I compare this person's standard deviation to the preceding person's standard deviation, do you notice that the new standard deviation is higher? That it's higher tells us that their grades are more spread apart. And so blanket statement that we're going to make is the higher the standard deviation, the more spread there is in the data. The higher the standard deviation, the more spread there is in the data. And I think the first time you go through and you make one of these tables and find the standard deviation, it can be overwhelming. It seems like a lot. As we look at it a second time, does it seem a little bit more manageable?
I have a question that's probably taking us way back.
Yeah.
How do you divide the square root?
How do you find the square root?
Yes, I can't bring it up in my brain today.
Okay, most people find it on their calculator.
Okay.
If you have a calculator like mine, look at it. You have a button for x squared. Above
Yes.
it, there's a little square root symbol.
Got it.
So
Thank
have
you.
to go second x squared and then type your number. In terms of finding it by hand, that was, oh my heavens, I'm old. That was something that we learned how to do back in the day in elementary school, was find the square root by hand. And it was a long drawn out algorithm. By the time I started teaching, which was, much later in my academic career, people no longer used that algorithm, but kind of just did a guess and check. Well, 162 is somewhere between 144 and 169. So it's somewhere between 12 and 13. Let me take a guess. Oh, that's too big. That's too small. And you kind of narrow it down from there. But there is an algorithm for finding the square root of a number. But are you all right? Because 162 is somewhere between 144, which is 12 squared, and 169, which is 13 squared. It makes sense that we should have a number in between the two. And
Yes.
you can use a method of guess and check to find the square root. You can use the old-fashioned algorithm, doing it by hand, which if we had time, I'd teach it to you. But I'm guessing that it's not something that you would use in your lives. Otherwise, I don't think many people do it by hand anymore. And so it's just, we're looking for a number that when I multiply it by itself, it takes me to that 162.5.
Thank you.
Okay,
Yes.
so having seen that done out, I'm going to move the class out of the way a little bit so I can add up a page. Let's look at student D, whose mean was also 85, but their range was huge. It was 75. Let's find their standard deviation. And for those of you who did not save it, their grades, they had 400s, pretty good. But then they bombed and got a 25. Remember, you're going to take the mean, you're going to take each value minus the mean. After you do those subtractions, you're going to square them. The number of grades is 5, so one less than the number of grades is 4. And I'm going to shut up and ask you folks to finish finding that standard deviation. Give you a minute to try it on your own. Harley, you came in late, yes? I'm going to stop sharing my screen so that I can work on this while you guys are working on it, and then we'll come back and compare results. Zorianne, I'm glad you're here. Looking at the chat.
Completely lost connection with that. I felt
Yeah.
like, oh no. Oh,
All right.
Hey, okay.
Is anybody else done yet, or do I need to be patient?
I'm good.
Okay, did anybody else get something near 33.5?
No.
And again, the reason I'm rounding this to the nearest 10th is because my data is whole numbers. And so one decimal place to the right of a whole number would be the 10th. And let me just double check. Oh, I made a mistake.
What?
No, I didn't. I didn't
Okay.
apologize. I'm just misremembering what I wrote. Yeah. Okay. So did everybody get their deviations to be 15, 15, 15, 15, and negative 60?
Yes.
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 Mhm.
Squared 15 is 225. Squared negative 60 is positive 3,600. So that column adds up to 4,500.
Mhm.
Did everybody remember that while the sample size is 5, because we're using the formula for the sample deviation, we're not going to divide that 4,500 by 5, but rather by 4, which gives me 1,125.
Mhm.
That's my variance.
Yes.
To find the standard deviation, I take the square root of that, which is approximately 33.5. Yes, no, maybe.
Yeah.
Do we want to try another one before we move on or no?
Yeah, please.
Okay. So for the last one, there's one student one student we didn't look at the standard deviation for, and that was student C. And again, their mean was also 85. Their range, I believe, if I remember correctly, was 40. And filling in the table, their grades were, I have to go back and look, 100, 60, 85, 85, and 95. I'm going to give everybody a minute to get that down, and then I'm going to stop sharing my screen so I can do it too, because this one I actually don't think I have pre-worked out. Again, the headings are the mean, the deviations, and then the deviations squared.
Okay.
I'm going to stop sharing. Going to become greedy and stop sharing.
Can you just put it back up for just 1 second so I can make sure I got everything down?
Sure. Let me know when you got it all.
I've got it. Thank you.
You're welcome.
Okay.
Right. Yeah. Is everybody done or still working?
Done for me.
Done for you.
I'm done.
Am I still, should we wait a minute?
No.
Now, did anybody else get something close to 15.4?
That's what I
Yes.
got.
Yes. Are we feeling any better about doing these?
A little bit.
Yeah, a little bit.
All right. And again, on a test or quiz, I would start with the, I'll have the table there for you. And I'll also have the formula for you that the standard deviation is the square of the sum of the deviations squared divided by 1 less than the number of values. So both will be there. Oh, actually, you know what? I lied. I'm not giving you guys pencil and paper tests. Pencil and paper tests, I provided both for them. My math lab tests, what they'll provide for you is what's provided in my math lab. Okay?
Okay.
All right. So this is a lot of work to go through to say whether values are very far apart or very close together. The range gave us a handle on that. Why are we going through all of this work to find the standard deviation? And the reason is because the standard deviation becomes a very powerful tool in statistics when we look at something that's called the normal distribution. And in order for something to be a normal distribution, it has to, first of all, be a large population. We're looking at large groups. So instead of, let's say, just looking at the students in class, I might be looking at the enrollment of the college. Now, if I have a large population, if it behaves normally, what usually happens is that the mean, the median, and the mode are approximately equal. So let's talk about what that says. Let's think about everybody at the college, and let's go through and try to think about, you know, something silly like their heights. And so let's say I got information from everybody at the college, students and faculty alike, and I found the average height. That would be the mean. Then let's say I got everybody all in one place and lined them up from shortest to tallest. Wouldn't you expect the middle of that line to be close to the average height? The median is about the mean.
Yeah.
And wouldn't you expect most people to be right around that average height, where the mode would also be close to the mean?
Yes.
I guess. Yeah.
And so the mean, median, and mode are approximately the same. And the reason it's called a normal distribution is because it occurs a lot. It occurs in so many things. It just naturally occurs. If I were to look at things like weight, if I were to look at things like, if I were a farmer and I was to look at the performance of a certain type of seed, it would fit the natural distribution. If I were a scientist and I were looking at like rainfall in different places or whatever, it would probably fit the normal distribution. It occurs a lot. If I were to be researching the price of something like a car and looking at the different prices for it, it should hit the normal distribution. Many things fit the normal distribution. That's why it's called normal.
Mhm.
Then the next thing that occurs is the frequency decreases as data values. Get further from the mean. What does that mean? Let's picture that line we have of people from shortest to tallest. Most people towards the middle of the line are about at this height. And then as we start getting further and further away, if we start looking at people, super tall, like the basketball players that are almost 7 feet tall, do we expect many people to be that height?
No.
No. If we look at people super short, those of us who are under 5 foot tall, do we expect many people to be down there? No. Most people are close to the average, and as I get away from the average, fewer people have that height. And then the other thing that occurs is the frequency polygon is relatively symmetric. And it gives us something that's called a bell curve. And so let's try to look at this frequency polygon. Again, the height would be the frequency. My sideways writing is a little sloppy, sorry.
Mhm.
And this would be my data values. And I'm going to look for about the middle of my number line here. And I'm going to label that my mean. By putting it in the middle of the number line, I'm like assuming it's the median. And whatever its frequency is, that's going to be the highest of my frequency distribution, telling me that it's the mode. And the further I get away from the mean, my frequency drops and it tails off. And it's relatively symmetric. So if I were a good artist, it would look like I'd have a mirror image on the other side, but I'm not a good artist. And so what we're saying is the frequency goes down as I go away from that middle. And so if this was like the average height, we'd expect most people to be there. We'd expect that to be the middle of the list. And then as people got shorter than the average, we'd expect as they get more and more short, less people to have that height. And over here on the other side, as we got more and more people who are tall, we'd expect that frequency to go down too. And I'm looking at the fact that we have 3 minutes left. And where we would go from here in 3 minutes, we can't do it justice. So I hate ending class early because I feel like I'm not giving you guys your tuition's worth. But because 3 minutes isn't going to give us enough time to actually develop this concept fully, do you guys mind if we stop here today?
No.
No? Okay, before we stop, I just want to make sure that I got everybody who came in today. Is there anybody who came in after attendance that I did not get? Anybody not hear me call their name during roll?
Kylie.
I got you, Kylie. I saw you come in and I got you while you guys were working on the problems. Also, to reiterate that executive decision that we made as a group, it's a 10-point quiz, so I'm going to give, I guess, 2 points extra credit to everybody who got it done before midnight last night.
Okay.
If you need extra time, I'm not going to just blanket open the quiz. You have to send me an email and ask me for extra time for me to give you extra time if you did not complete it. All right?
Thank you.
And just to ask,
Sure.
what's the quiz on Friday going to be about again? Just mean, medium?
Median, mode, and mid-range.
Okay,
Okay.
I'll study up for that then.
All right, okay. Then
Thank
have a
you.
great day, you guys, and we'll
You
see
too.
you on Friday.
Good
Bye-bye.
luck on the
Alright, you
baby
too.
weight.
Yeah, you know
See
what?
ya.
I guess I'm not gonna worry about it. I'm gonna just hope she's okay and she's not worrying about it. So,
Okay,
thanks.
Good.
All right,
bye-bye.
bye-bye.
All right, I don't know how to, can you hear me? You're still recording.
Okay, I stopped.